Okay, today we're looking at section 5.4, how do you factor and solve polynomial equations. So last chapter we talked about factoring and we worked on factoring quite a bit. This section is going to take factoring a little bit further into polynomial functions. So instead of having x squared terms, we might have polynomials with higher degrees than squared. Okay, and it might make it a little bit more difficult, and we'll have a few more steps on our factoring here. So the general steps here are right here. So always look to see if you can factor a greatest common factor first. So does something factor out of each term? Then we look for special factorizations like difference of squares, which we've seen before, or sum or difference of cubes, which we have not seen before, but it's in this section. Okay, and then finally we look for trinomials to factor from there. Okay, so let's start with these first four here. Slide this up a little bit. So looking at number one, if I want to factor that, looking for a greatest common factor first, these three terms all have an x in them, so I'm going to factor out an x. And what I would suggest doing is maybe trying these problems ahead of time. These first four, pausing the video, try them, and then go through the solutions. So this first one, I'm going to factor out an x. That's going to leave an x squared minus 7x plus 10 from there. Now we have to look and see if we can factor it further. Is there any special factorizations? No. Can we factor the trinomial? Yes, we can. So this one is just the diamond problem type. Two numbers that multiply to get 10 that add up to negative 7. That would be 5 and 2, both negative. Negative 5 times negative 2 is 10. Okay, so this would be completely factored. We can't go any further. Second one, in this case, we have two terms here. Before we look for any special factorization, what factors out of each term? Does 3 go into 75? I think it does. And also I can factor a y cubed out of both terms. So I'm going to factor a 3y cubed out of both terms. And what's left? We'd have a y squared minus 3 goes into 75 25 times. Okay, now what is this? We should recognize that as a difference of squares. Difference of two perfect squares. So do we remember how to factor that? That factors to y minus 5, y plus 5. Okay, remember two numbers that are the 5 squared is 25, and then we have a plus and a minus there. Okay, finally this one. 4 goes in each term, and there's an x squared in each term. So I'm going to factor 4x squared out. That's going to leave me with an x squared minus 4x plus 4, and then I can factor that further. Multiplies to get 4, that adds up to negative 4. That would be a minus 2 and a minus 2, and because those are the same, we could actually write it like this, squared. Okay, finally the last one, looks like 3 goes in each term and there's an x in each term, so I'm going to factor a 3x out of each term. That's going to leave me with a 2x squared minus 3x minus 9. Okay, now this factors, and this one's going to be a little more difficult. This is our factoring by grouping process here. So remember, we do the diamond problem, multiply this, we get a negative 18 and a negative 3. What multiplies to get negative 18? That adds up to negative 3. That would be negative 6 times 3. So then I'm going to rewrite this as 2x squared minus 6x plus 3x minus 9. Then I do my factoring by grouping. I should have left myself more room, but we'll see what happens here. Actually, I'll write this up here. So we're going to have a 3x, and then I factor the 2x out of that. And that leaves me with an x minus 3, and I can factor a 3 out of this, and then I can factor the x minus 3 out of each. So I got a 3x, x minus 3, and a 2x plus 3. So that would be completely factored. So we're always going back to all of the other factoring that we know. We're just applying several steps on this process. Okay, special rules. Sum or difference of cubes. This we haven't seen before. It's on page 354 in your book. I also rewrote it here. If I see a sum of two perfect cube numbers or variables, it factors into this. So a cubed plus b cubed equals a plus b times the quantity a squared minus ab plus b squared. If it's a difference of perfect cubes, it looks like this. All that changes is the signs. Notice this is a minus, this is a plus, and this one, this is a plus, this is a minus. Okay, so we have to recognize perfect cube numbers. Like 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. We should maybe write them on the side. I'll write them on the side. Four cubed is 64. 5 cubed is 125. 6 cubed is 216. 7 cubed is 343. And we could keep going. But we should recognize those numbers. Okay, so in this first one, I have a sum of two perfect cubed. 3 cubed is 27. So I would follow the sum of cubes here. So this is x cubed plus 3 cubed. So a is x and 3 is b. So this would factor into x plus 3. And then x squared minus 3x plus 3 squared, which is 9. So that would factor 2. This one, what do I cube to get 8? 2, so this is actually 2x quantity cubed minus 4 quantity cubed. So a is 2x and b is 4, and we're following this one here. So this is 2x minus 4, and then 2x squared. When I square 2, I'm going to get 4x squared plus 8x, 2 times 4, 8x, and then plus 4 squared is 16. Now two factors out of this, so technically I could have factored a 2 out and got x minus 2, and I could have factored a 4 out of this, and that would give me x squared plus 2x plus 4, and then I can multiply the 2 by 4 and get 8, x minus 2, x squared plus 2x plus 4. Instead of doing all that, I probably could have factored 8 out right away, which is what I should have done, and then done the difference of cubes from there. But it works either way. Okay, last one here. Difference of cubes here. 2 factors out of this. Actually, a 2x squared factors out of this. And then I get left with 8x cubed plus 343. Okay, 8 is a perfect cube, 343 is 7 cubed. So this ends up being 2x squared, and then this would be a 2x cubed plus 7 cubed. Okay, so that's going to factor then, follow the sum of cubes. So I get 2x plus 7, and then 2 squared is 4, so 4x squared minus 14x, 7 times 2, and then 7 squared is 49, plus 49. So that's what I get on that one. So that's sum or difference of cubes. Basically, we have to recognize it, know what we're cubing, and then just substitute it into the proper formula there. Okay. A couple other types of factoring. Factoring by grouping. Sometimes if I have a cubed, a squared, an x, and a constant, I can factor this cubic using factoring by grouping. Similar to how I did factoring by grouping when I factor a squared term with a coefficient greater than 1. So we do the factoring by grouping. So what factors out of these two? An x squared does. Leaves me with an x minus 3. What factors out of these two? 16 does. So if I factor a negative 16 out, this is going to give me an x minus 3. Let's check it. Negative 16x. Negative times a negative gives me a positive 48. So then I factor the x minus 3 out of each term. Leaves me with the x squared minus 16. Now we have to notice that this is a difference of squares. So this actually factors one step further. Plus 4 x minus 4. Okay. Let's try this one. A cubed, a squared, an x, and a constant. So think factoring by grouping. Factor out an x squared here. X plus 7. What factors out of these? Negative 9 does. That leaves me with another x plus 7. And then factor the x plus 7. And then we have the x squared minus 9. And again, I get a difference of squares. Plus 3 minus 3. Now every time we do this, we don't always get a difference of squares. It just happened to work out that way in these two problems. Okay. So that's factoring by grouping. Anytime we see a cubed, a squared, an x, and a constant, consider factoring by grouping. Quadratic form types. These are in a form for standard factoring but are different exponents. For example, this one, 16x to the fourth minus 81, is actually a difference of squares, even though this isn't a squared term. Okay, what would we square to get this term here? Well, we'd square 4x squared would give me 4 squared is 16, x to the fourth. And what would I square to get 81? 9, right? So this factors to 4x squared minus 9 and 4x squared plus 9. Okay, it's a difference of squared, but it's a fourth power. Now we can even take this further, because after we've factored this, now this is another difference of squares. So we can go further. That actually factors to 2x minus 3, 2x plus 3. That's a difference of squares. This one does not factor any further, so we just leave it. Okay. Now look at this one. This one doesn't look like anything we've done before. It's not factoring by grouping because it's not a cubed, a squared, an x, and a constant. However, this can be factored the same way as if I was factoring this. Okay, so how would I factor this? This is easy because all that is a diamond problem type, where I'm trying to find two numbers that multiply to get negative 15 that add up to negative 2, which would be negative 5 times 3, right? So this would be x minus 5, x plus 3. So that's how I would factor this. This is factored the same way. The only difference is it's going to be x squared minus 5 and x squared plus 3. If I FOIL this out, x squared times x squared is x to the fourth. X squared times 3 is 3x. This times x squared is negative 5x. That adds up to negative 2x. And my last terms multiply out there. So this quadratic form type we factor just like a trinomial. What you'll notice is the exponent on this term is half the exponent on this term. And that would indicate that I could do quadratic form type. I can factor it just like a regular trinomial there. Okay. All right. Last part here, solving equations. All we're taking it is a step further, and we're actually solving equations. So in order to solve this equation, we have to factor. Okay, so we have to first identify what type of factoring it is. So the first thing we always look for is, does something factor out of every term? Looks like I have an x in every term. I can factor out a 4, so this becomes a 4x. And that leaves me with an x to the fourth minus 10x squared plus 9 equals 0. Okay, now I have to look on the inside here. What kind of factoring is it? Well, it happens to be this last one here, this quadratic form type. This is half of this exponent, so it's just going to be a simple quadratic form type. So this is going to be an x squared and an x squared. Two numbers that multiply to get 9 that add up to negative 10 would be negative 1 times negative 9. So that's what I get there. We're not done now, because what are these? These are difference of squares. So that factors one step further. So that's x plus 1 and x minus 1. And this is x plus 3 and x minus 3. Okay, so now I can find my solutions. I have to set all these factors equal to 0. So if I set 4x equals 0, my one solution is x equals 0. If I set x plus 1 equal to 0, I'll get x equals negative 1 for a solution. This is going to give me x equals 1. This is going to give me x equals negative 3 and x equals positive 3. So I have 1, 2, 3, 4, 5 solutions. And one thing we'll find out in the future is whatever the degree is, that's the maximum number of solutions we can have. Okay, we're running out of time here, so let's do this last one. Cubed, a squared, an x, and a constant. So this is factoring by grouping. Let's factor an x squared out of that. Gives me an x plus 6. Factor a negative 4 out of this. Gives me an x plus 6. And then I get factor an x plus 6. And then I get x squared minus 4. This is a difference of squares. So that's going to be x plus 2, x minus 2. So I've got a solution of x equals negative 6, x equals negative 2, x equals 2. Okay, so that concludes section 5.4.